Hello again, gang. Mr. Cruze here, working through yet another Algebra 2 review for you. This time over the 7.1 to 7.5 quiz, which will be tomorrow, Friday, March 22nd. Alright, Friday before spring break. Here we go. The first four just ask you to graph. So, number 1, y equals 2 times 3 to the x. Well, since this is an exponential function, I'm just going to go ahead and make that t-table, right? For all these exponential functions, we're going to use -2, -1, 0, 1, and 2 for our x coordinates. And then we'll just have to figure out the y's. Now, a couple ways you can do this. We can go ahead and just do 2 times 3 to the x if you want. Or you can do 3 to the x, figure out that, and then multiply your y coordinates by 2. Either way works. I'm going to do the first one. So I'm going to plug in all my x values into that. Okay? So 3 to the -2. You plug that in your calculator, you get 0.1 repeating, and you double it and you get 0.22. We'll just go with that. 3 to the -1 is obviously 1/3, which is 0.3 repeating, and times 2 will be 0.67. Okay, 3 to the 0 is 1, times 2 is 2. 3 to the 1st is 3, times 2 is 6. And 3 squared is 9, times 2 is 18. Obviously it goes off the graph, but remember, I'm looking at your t-table and your graph together. Since there's nothing being added on out here, I know my horizontal asymptote is y equals 0. So I know not to go above or below that line depending on which way my graph goes. So -2.22 is right here. -1.67 is right here. 0.2. 1.6. It's right there, and then here's my graph. Now, what am I looking for in this graph? I'm obviously looking for the double arrows. Make sure you have both ends of the arrow. Your graph has to go both ways. It can't go below your horizontal asymptote again, and then just obviously make sure the points are in somewhat of a correct location. I wouldn't want your graph over here. That would obviously be wrong. Okay? There's that. Number 2 is y equals log base 5 of x, and for the most part, it's almost the same kind of stuff. The only thing is I need to get it into an exponential, and then I can make the t-table. So I need to switch the x and y. That's the first thing I need to do. Once I do that, I need to get the y out of the log. So to do that, I bump the base, which is 5. So 5 and log 5 cancel, and you're left with y equals 5 to the x. That's the inverse of y equals log base 5 of x. This is the inverse. Okay. So let's make a t-table for that. And we just learned how to do that. -2, -1, 0, 1, and 2. 5 to the -2 should be 0.04. 5 to the -1 should be 0.2. 5 to the 0 is 1. 5 to the 1st is 5, and 5 squared is 25. Okay. But this isn't what I need to graph. I need to graph the original. Okay. To do that, well, what was the first step that I did? I flipped the x and y. So guess what I'm going to do here? Flip the x and y. So this would be 0.04, -2, 0.2, -1, 1, 0, 5, 1, and 25, 2. And then I can graph it. So it would be, let's see, 0.04, -2 is right here. 0.2, -1 is right here. 1, 0, 5, 1. And obviously 25.2 is too big to graph, but here we go. Once again, double arrows. And this time it has a vertical asymptote of x equals 0. Okay? Nothing added or subtracted on inside the x, so I know we're good. So don't go across that vertical asymptote. Okay? You do not have to graph the blue one to graph the red one. You just need to flip the t-table. Okay? Number 3 is yet another exponential, so we don't have to flip any t-tables. We can just go ahead and make it. So let's make a t-table for 5 times 3 to the x. Let's go ahead and do that first, and then we'll move it. Same x values, -2, -1, 0, 1, and 2. 3 to the -2 will be 0.1 repeating again. Times 5 will be 0.5 repeating, so we'll go 0.56. 3 to the -1 is 0.3 repeating. Times 5 is 1.67. 3 to the 0 is 1, times 5 is 5. 3 to the 1st is 3, times 5 is 15. 3 squared is 9, times 5 is 45. Okay? Now we just have to move it. Okay? And to do that, we're going to do the opposite of what we see and subtract 1 from x, and we're going to subtract 2 from y. Okay? So let's do that. Let's subtract 1 from all our x coordinates. Well, that would be -3, -2, -1, 0, and 1. And if you subtract 2 from your y's, you get -1.44. You'll get -0.33. You'll get 3. You'll get 13 and 43. And then you can graph it. Right there. There, and obviously it's going to go off your graph. It's going to keep going that way. And you have a horizontal asymptote right there of -2, so you know your graph really can't go below that horizontal asymptote. Mine's pretty close, so I'm going to fix it because I don't want to lose any points for that. Again, I just don't want to make I want to make sure you're not graphing just, you know, something like random, okay? Number 4, it's a log, so I have to flip the x and y in order to graph it. So x equals log base 3 of y minus 2 plus 4. Can't bump the base yet. I have to subtract 4. And that equals log base 3 of y minus 2. Now you can bump the base. Bump that base. Anyway, y minus 2 is going to equal 3 to the x minus 4. But I'm going to add 2 to both sides, so here's what I'm really going to be graphing. Okay? If this is okay with you, I'm just going to erase all this nonsense work because we don't need it anymore. This is what I need to make a t-table for. Well, first I'm going to do 3 to the x, and then we'll move it. Okay? 3 to the -2 is 0.11. 3 to the -1 is 0.33. 3 to the 0 is 1, 3, and 9. Now I need to move it. That's going to be right 4. So I'm going to add 4 to all my x's. And this will be up 2. So I'm going to add 2 to my y's. So basically, if you want to think about it this way, we can do, you can almost do it like this. If you want x plus 4, that'll be 2, 3, 4, 5, 6. And all your y's plus 2 will be 2.11, 2.33, 3, 5, and 11. But this isn't what we're graphing. This will be the t-table for this function, right? And that's not what I want. I want to graph this. So what do I have to do? Flip the x and y once again. So here we go. 2.112, 3, 2.33, 3, 3, 4, 5, 5. Ooh, they're going to meet at that point. And then 11, 6. So here we go. 2.112. Be right there-ish. 2.333. 3, 4. 5, 5. And that last point's going to be tricky to graph. So there's your graph. Okay. Once again, vertical asymptote this time of x equals +2. Okay. So make sure it doesn't go left of that line. All right. Oh, right, 3 to the 4th equals 81 in logarithmic form. That's not so bad. To undo the 3 to the 4th, I'm going to take the log base 3 of both sides. And the reason for that is because the log base 3 of 3 cancels. So it becomes 4 equals log base 3 of 81. And that's my final answer. That's logarithmic form. To go backwards from logarithmic to exponential, you would bump that base.